Hello there, and welcome to Sleepy Orbit Channel. I am pleased you found your way here tonight, whatever hour it happens to be where you are lying, whatever the day behind you managed to ask of you before it let you go. You do not have to tell me how it went. You do not have to summarize it, or defend it, or find the lesson in it. You only have to be here, horizontal, breathing, with the lamp low or off entirely, and let a voice do the small work of company for a while. Tonight I want to ask you a question that sounds like an engineering problem and turns out to be something closer to a lullaby. How long would it take to reach TRAPPIST-1? There is a star out there, small and red and older than our sun, with 7 worlds wrapped around it like beads on a very short string, and it sits about 40 light years away from the room you are lying in. 40 years of travel, if you happen to be light. Hundreds of thousands of years, if you happen to be us. And here is the beautiful contradiction I want to hand you before you drift. The answer to this question is enormous. And the enormity is not a problem. It is not a wall. It is a kind of permission. When a distance is that long, no one can be late. When a journey takes longer than every empire that has ever existed, there is nothing left to hurry for. The trip stops being an errand and becomes a condition, like weather, like sleep. That is the paradox I would like to lay beside you. A voyage so long that it turns into rest. We will take 4 unhurried paths through it. First, we will learn what the place actually is, this dim ember called TRAPPIST-1, and the 7 rocky worlds that circle it in a tighter ring than the orbit of Mercury. Second, we will look at how it was found, in a dry, high desert in Chile, by people watching for a star to dim by less than 1%. Third, we will count the journey honestly, in every vehicle we own, and every vehicle we have only dreamed, from chemical rockets to sails made of light. And fourth, we will sit with what the distance does to us, to time, to arrival, to the strange comfort of a destination no one alive will touch. If this kind of thing helps you sleep, a like or a subscribe helps the channel reach other people also lying awake at this hour. That is all. It costs you nothing, and you can do it tomorrow, or never. None of this needs anything from you tonight. You do not have to follow the numbers. You do not have to remember a single name. Let your shoulders ease down away from your ears. Let your jaw come unclenched. Let the tongue rest low in the mouth. Let the hands open a little where they lie. Let the breath out be longer than the breath in, without forcing it, the way a tide does not force itself. Let's begin. Let us start with the distance itself, because everything else tonight hangs from that one number, and because the number is worth holding slowly. TRAPPIST-1 is about 40.7 light years from here. That is the figure the measurements settle on, and the way we get it is almost absurdly simple in principle. The Earth swings around the Sun once a year, which means that in January we are standing in one place, and in July we are standing about 300 million kilometers away from that place. A nearby star, seen from those 2 positions, appears to shift by a hair against the deeper background of far-off stars, the same way your thumb held at arm's length jumps sideways when you close one eye and then the other. Measure the size of that jump, and you have the distance. For TRAPPIST-1, the jump is tiny, a fraction of an arcsecond, a shiver of an angle, and out of that shiver comes 40.7 light years. Now, a light year. We say it so often that it has worn smooth, so let me roughen it up again for you. Light is the fastest thing there is, and not by a comfortable margin, but absolutely, structurally as a property of how the universe is stitched together. It moves just under 300,000 kilometers every second, In the time it takes you to think the word now, light has gone around the Earth about 7 times. It crosses from the moon to your eye in a little over a second, which is why the Apollo radio conversations have that faint pause in them, a hesitation built into physics rather than into the people speaking. It takes 8 minutes and change to fall from the sun to your face on a summer afternoon, which means the warmth on your skin left home before you woke up thinking about it. Give that same light a year to run, a full year, all 4 seasons of it, every night and every day, never slowing, never resting, never once pausing to consider the view. In that year, it covers about 9.5 trillion kilometers. Trillion is a word that has been ruined by finance. Let me put it back into your body. If you began counting seconds right now, out loud, 1 per second, without sleeping, you would reach 1 trillion in about 31,000 years. That is the number of kilometers in a single light year, 10 times over. And TRAPPIST-1 is 40.7 of those. Multiply it out, and you get something like 385 trillion kilometers. I am not going to pretend that number means anything to a human nervous system. It does not. Our sense of distance was built for the walk to the river and back, for how far a thrown stone goes, for the hill you can see from the hill you are standing on. 385 trillion kilometers is not a distance we can feel. So let me translate it into something you can lie down inside. Imagine you shrink the whole thing until the Earth's orbit around the Sun is the size of a dinner plate on a table in front of you. The Sun a bright grain at the center, our whole planet's yearly circuit a ring you could cover with one hand. At that scale, where would TRAPPIST-1 be? Not on the table, not in the room, not in the building. It would be roughly 170 kilometers away, a 2-hour drive on an open road out past the edge of the city, past the suburbs and the fields and the second range of hills, in some other town where other people are also lying in the dark tonight. That is the emptiness we are talking about. A dinner plate here. Another dinner plate 170 kilometers away, and between them, nothing but a scattering of atoms so thin that a cubic centimeter of it might hold a single hydrogen atom, alone, drifting, unbothered. I want to introduce the thread that will run through everything tonight, because it will come back again and again, and I would like you to know it by name before it does. Every long space voyage has 3 parts, and only the middle one matters for us. There is the burn at the beginning, when the engine is lit and everything shakes, and the numbers are frantic and the fuel pours away. There is the burn at the end, if you intend to stop. And between those two, filling almost the entire duration of any real interstellar trip, there is the coast. The coast is the part where nothing is required. In the vacuum between stars, there is no air to push back against you, no road to roughen under you, no friction worth the name. So once you are moving, not because you keep trying. Because there is nothing out there to make you stop. The engine can be cold and dark and long since drained. The crew can be asleep. The century can turn over 4 times, and the ship holds its speed exactly, silently, without effort, without maintenance, without anyone watching. That is Newton's first law taken to its most generous conclusion: motion once given is kept for free. That is what I mean when I say this journey is a form of rest. The overwhelming majority of any trip to TRAPPIST-1 is coasting. Not striving, not accelerating, not fighting, just carrying and being carried through a dark so smooth it offers no resistance to anything at all. Hold that. We will come back to the coast many times before you fall asleep. Now let me tell you what is waiting at the other end of it. TRAPPIST-1 is a star, but it is nothing like the star you know. Our Sun is, by galactic standards, a fairly large and rather energetic object, a yellow-white furnace that has been burning for 4.5 billion years and will burn for about 5 billion more before it swells and sheds and dies. TRAPPIST-1 is what astronomers call an ultra-cool dwarf, and every part of that phrase is doing honest work. It is a dwarf because it is small. Its mass is roughly 9% of the Sun's. Its width is about 12% of the Sun's, which puts it at only a little larger than the planet Jupiter. Think about that for a moment before it slides past. There is a star out there, a real star, with fusion happening in its core that you could set beside Jupiter and mistake for its slightly bigger sibling. If you replaced our Sun with it, it would look less like the blazing disk we shade our eyes from, and more like a dull coal held at the far end of a long hall. It is ultra-cool because its surface is not the 6,000 Kelvin of our Sun, but something closer to 2,560. In color terms, it is deep red bleeding into the infrared, meaning most of what it radiates is not light your eyes would register at all, but warmth your skin would. If you could hang in space at a comfortable distance and look at it directly, without any instrument, you would see something like a hot ember at the bottom of a fire that has been left overnight, a salmon-colored glow with no glare in it, a light you could stare at without flinching. And its total output is about 1/20th of 1% of what our Sun pours out. 0.02. That is the entire energy budget of the place. But here is where the arithmetic turns tender, and I want you to hear this one properly, because it is the most consoling fact I know about small stars. A star's life is a negotiation between how much fuel it has and how fast it spends it. Big bright stars have enormous reserves and burn through them with such extravagance that they last only a few million years before they detonate. Our Sun is more moderate, 10 billion years, give or take. But a tiny red dwarf like TRAPPIST-1 is thrifty beyond imagining. It is fully convective, meaning the whole body of it churns and turns over like a slow pot of soup, which drags fresh hydrogen down into the core instead of leaving unburnt fuel stranded in the outer layers. It uses everything it has, and it uses it so slowly that its projected lifespan is measured not in billions of years but in trillions. Trillions. Some estimates run to 12 trillion years for a star of that size. The universe is currently about 14 billion years old. TRAPPIST-1 is roughly 7.5 billion years old, older than our Sun by a comfortable margin, and it has not yet finished the first 1,000th of 1% of its life. It is a newborn that will outlive every galaxy's ability to make new stars. Long after our Sun has become a white dwarf cooling toward invisibility, long after the Milky Way and Andromeda have finished merging into one shapeless elliptical smear, long after the last blue giants have died and the sky everywhere has gone dark and red, TRAPPIST-1 will be burning. Same ember, same patient rate, 7 planets going around it in the same rhythm they keep tonight. There is something in that I find deeply restful, and I offer it to you without argument. We tend to associate brightness with importance and heat with worth. The universe does not. The things that last longest are the ones that burn least. The dim, the modest, the unhurried, the ones that would never catch your eye across a crowded sky. They are the ones that will be there at the end, keeping their small circles, holding their small warmth. Long after all the spectacular things have spent themselves, Let that settle in the room with you for a moment. Nothing about you needs to burn brightly to last. Now, the 7. Around that ember, 7 worlds. We call them B, C, D, E, F, G, and H in order outward from the star, because astronomers name planets in the order they are discovered, and the letter A is reserved for the star itself. It is an unromantic system, and I have grown fond of it. 7 letters, 7 stones, going around and around a dim red coal in the constellation Aquarius. What makes them extraordinary is not just that there are 7, though 7 Earth-sized worlds around one small star was, when it was announced, the largest such family anyone had found. What makes them extraordinary is how close together they are and how close in they sit. In our own system, Mercury orbits at about 58 million kilometers from the Sun, which we think of as scandalously near. Every one of the 7 TRAPPIST worlds orbits closer to its star than Mercury does to ours. Much closer. The innermost sits at roughly 1/100th of the Earth-Sun distance. The outermost, the 7th, is at about 6/100ths. The entire system, all 7 planets, the whole architecture of that world family, would fit comfortably inside the orbit of Mercury, with room to spare. You could take the whole of TRAPPIST-1 and its 7 children and set them down inside the empty space between our Sun and its nearest planet, and they would rattle around in there like 7 marbles in a bucket. Which means their years are absurdly short. The innermost planet goes all the way around its star in about 1.5 days. Think of that, a year, a complete circuit, a full return to where you started in less time than a long weekend. The second takes about 2.5 days, the third 4, the fourth 6, the fifth 9, the sixth 12, and the outermost, the 7th, takes about 19 days. On that world, the whole cycle of a year, everything a year contains, everything a year means, happens in less time than a single one of our months. If you stood on one of them and kept a birthday, you would have 1,000 birthdays before you finished primary school. Now, the reason they can sit that close without being burnt to slag is that the star gives out so little. This is the elegant compensation at the heart of the system. A dim star has a habitable zone, that band of distances where liquid water could exist on a surface, but the band is drawn in very tight against the star, like people standing close around a small fire on a cold night. Around our Sun, that band is roughly where Venus, Earth, and Mars are. Around TRAPPIST-1, it is a narrow ring only a few million kilometers out, and 3 of the 7, the 4th, 5th, and 6th, planets E, F, and G, sit inside it, or near enough to argue about. I want to describe the sky from one of those surfaces because this is the part I return to when I cannot sleep. Stand on the 4th planet. The star hangs in your sky, and it is enormous. From that distance, it would look several times wider across than our Sun looks to us, a great dull scarlet disk taking up a real portion of the sky, rather than the small coin we are used to. But it would not be blinding. It would not hurt. Its light is thin and red and mostly infrared, so the dominant sensation would be warmth on the face rather than glare in the eyes. Imagine a permanent sunset that never descends, a horizon-colored light coming from directly overhead, everything beneath it rendered in rust and copper and deep rose, shadows long and reddish, the whole landscape looking like a photograph developed in warm chemistry. And then look for the others. Because the planets are packed so tightly, they pass near one another constantly, and when they do, they are not points of light. They are disks. From several of these worlds, the neighboring planets would appear larger in the sky than our full moon appears to us. Not a bright dot among the stars. A visible world with a curve to it, with a lit crescent and a dark portion, with markings if it has any, drifting past overhead and changing shape from night to night, and sometimes from hour to hour. You would grow up knowing the faces of your neighbors the way we grow up knowing the face of the moon. You would watch one swell as it approached and shrink as it drew away. You would see them line up. You would see one slide in front of another. There would be no need for anyone on that world to invent the idea of other worlds. It would be obvious from childhood. It would be the first thing anyone noticed about the sky. And now the strangest and most lovely fact about the seven, which is the thing that made astronomers sit up when the measurements came in. They are in resonance, all of them, every neighboring pair. Here is what that means. When you compare each planet's year to the year of the planet just outside it, the numbers do not come out as messy decimals. They come out as small whole number ratios. The innermost pair beat at 8-5, the next at 5-3, then 3-2, then 3-2 again, then 4-3, then 3-2 once more. Every pairing in the chain locks into a simple fraction. For every 8 laps the first planet runs, the second runs 5. For every 3 the third runs, the fourth runs 2. If you have ever pushed someone on a swing, you already understand the physics of this in your hands. You do not push randomly, you push in time. And because you push in time, tiny efforts accumulate into large, steady motion, and the system settles into a rhythm that holds itself. That is what gravity has done here over billions of years. Each planet tugs on its neighbors a little, every single orbit, and because those tugs arrive at the same point in the cycle again and again, rather than scattering randomly, they do not tear the system apart. They tune it. The whole configuration has fallen into a groove and stayed in it since it formed. Astronomers call this a resonance chain, and it is the longest unbroken one we know of. 7 bodies, all in step, all the way out. What it tells us is that these planets did not form where they now sit. You cannot build 7 rocky worlds in such a cramped space from scratch. There is not enough material that close in. They almost certainly formed further out, in the colder outer reaches of the young disk of gas and dust around the newborn star, where ice was plentiful, and then migrated inward through that disk. And as they migrated, they caught each other, and locked, and came down the slope together like a group of people descending a staircase in matched footfalls. They arrived where they are as a set. They have been keeping time ever since. You will hear people describe this as music, and they are not being merely poetic. If you assign a note to each orbital frequency and pitch them up into the range of human hearing, the ratios that come out are the ratios of a musical scale. 3-2 is a perfect fifth. 4-3 is a perfect fourth. 8-5 is very near a major sixth. The intervals that our ears learned to call consonant thousands of years ago, sitting around fires and plucking strings, are the same simple fractions that gravity finds when it has enough time to settle a system of worlds into a stable arrangement. There is no mysticism required. Both are the same mathematics of small whole numbers appearing once in a string and once in an orbit. So there is a chord out there. It has been sustained for billions of years. It was sounding before there were bones on this planet, before there were eyes, before there was oxygen in our air. It is sounding now. It will be sounding long after everything here has changed beyond recognition. I find that a good thing to fall asleep to. Not because it means anything about us. Because it does not need to. There is one more feature of these worlds to place beside you, and it is the one that shapes what a day would be like there. Being that close to their star, all 7 are very likely tidally locked. The star's gravity has gripped them and slowed their spin over aeons until each one turns exactly once per orbit, which means the same face is held toward the star forever. This is the same process that has locked our moon to us, which is why we have always seen the same lunar face and never the far side, not once in all of human history until we sent cameras around the back in 1959. Tidal locking means those worlds have no day and no night in the way we mean it. They have a hemisphere of permanent daylight, where the red star hangs fixed at the same spot in the sky and never moves, never rises, never sets, hour after hour, century after century. And they have a hemisphere of permanent darkness, where the star has never once been seen, where the only light is starlight and the reflected glow of neighboring planets swinging past, and between them, ringing each world like a seam, there is the terminator. That is the band where the light ends. A ring of perpetual twilight running pole to pole all the way around, where the star sits permanently on the horizon, half risen, half set, never committing. If those worlds hold atmospheres and water, that ring is where the interesting things would be. Not too scorched, not too frozen, held in a long, unmoving dusk. Winds would pour from the hot side to the cold side across it. Clouds would pile up on the day face, and rain would fall along that seam. And the light there would be permanently horizontal, permanently red, permanently the color of the 10 minutes after sunset that photographers chase and never quite catch. Imagine living in that. Not a life of days and nights, but a life of positions. You would not say, "I will see you tomorrow." You would say, "I will see you when I have walked so far." Weather would come from a direction, not a season. Your sense of time would have to be built out of something other than the sky, because the sky would never change. And the strangest, most restful part, on such a world, no one would ever be woken by the sun coming up. Light would simply be where it is, and dark would be where it is, and you would go to whichever you needed. We do not know whether anything lives there. We do not know whether those worlds have held onto their air at all. There is reason for caution, which we will get to honestly later, and there is reason for hope, and both are fine to hold at once at this hour. What we do know is the shape of the place. 7 stones, in step, around an ember, in permanent red twilight, 40.7 light years from your pillow. Now let me tell you how anyone found out. The story begins, as so many astronomical stories do, with somebody deciding to look at the boring things. For most of the modern history of planet hunting, the search was aimed at stars like our own. It made sense. If you are looking for another Earth, look near another sun. Sun-like stars are bright, they are well understood, they are easy to model, and the instruments were built for them. Ultra-cool dwarfs, the little red embers, were considered poor hunting ground and mostly left alone. They are faint. They are numerous, but dim. Scattered through the neighborhood like coals raked out of a fire, most of them too feeble to see with the naked eye from anywhere on Earth. TRAPPIST-1 itself, despite being one of our closer neighbors, is far too faint to see without a telescope. You have looked straight at that patch of Aquarius on some summer night in your life and seen nothing there at all. But a small group of astronomers, working out of the University of Liege in Belgium, made a contrarian argument in the early 2000s, and the argument went roughly like this. If you want to find a planet by watching it cross in front of its star, 3 things work in your favor when the star is small. First, a small star is dimmed proportionally more by a planet passing across it. An Earth-sized world crossing the face of our sun blocks about 1 part in 12,000 of the light. A signal so faint that it took a space telescope in a perfect environment to see it. That same world crossing the face of TRAPPIST-1 blocks nearly 1% of the light. Because the star's disk is barely bigger than Jupiter, 1% is a signal you can catch from the ground with a modest telescope on a good night. Second, the habitable zone around a small star is very close in, which means any planet sitting in it has a year measured in days, which means it transits often, which means you do not have to watch for a decade to catch 3 passes. And third, small stars are the most common stars in the galaxy by a wide margin, so if they turn out to have planets, then most planets are around them. The counter-argument was that these stars are faint and hard to work with, and the answer to that was yes, but there are so many of them, and the signal is so much larger, and nobody else is looking. So they built a small telescope and pointed it at the boring things. The instrument was called TRAPPIST, which stands, with the specific gleeful contortion that astronomers apply to acronyms, for the Transiting Planets and Planetesimals Small Telescope. It is a 60-centimeter robotic telescope. 60 centimeters. That is a mirror about the width of a bicycle wheel. There are amateurs with larger instruments in their back gardens. It sits at the La Silla Observatory in Chile, on a ridge at the southern edge of the Atacama, one of the driest places on the surface of this planet, where the air is thin and dry, and the sky at night is so black between the stars that visitors describe the Milky Way casting a shadow on the ground. And, because the team was Belgian, the name was also an affectionate nod to Trappist beer, brewed by monks in abbeys across their country. Slow fermentation. Long patience. Small operations producing something of unreasonable quality. I have always thought it was a more fitting metaphor than the acronym. The telescope was robotic, which meant it worked alone. Night after night it opened, oriented itself, and stared at one dim red star after another, taking image after image, measuring how much light arrived, writing the numbers down, and doing it again. There is no drama in that data. It is a column of near identical brightness values, thousands of them, hour after hour, nothing happening, nothing happening, nothing happening. That is the actual texture of discovery, and I want you to feel it rather than the version in films. Almost all of astronomy is a machine in the dark, in a country far from where the astronomers sleep, measuring the same faint thing over and over, producing a flat line that means nothing yet. And then, in the autumn of 2015, the flat line bent. Watching a star called 2MASS J230-62928-0502285, an object so obscure it had only a catalog designation for a name. The team saw the brightness drop by a small fraction and then come back. And then, on another night, drop and come back again, and again. 3 different dips, with 3 different depths and 3 different rhythms, which meant 3 different objects passing between that star and the telescope. They published in 2016 3 Earth-sized planets around an ultra-cool dwarf. That was already remarkable. The star got a friendlier name, TRAPPIST-1, after the telescope that found it, and it stopped being a catalog number and became a place. But the rhythms were not quite adding up. The 3rd signal was inconsistent, appearing at times that did not fit a single tidy orbit. Something was wrong, or something was being missed, and the way to settle it was to watch continuously, which you cannot do from the ground, because the ground keeps turning and taking the sky away from you every morning. So they asked for the Spitzer Space Telescope. Spitzer was an infrared observatory in orbit around the Sun, trailing behind the Earth, drifting further from us each year, cooled and dark and exquisitely sensitive to exactly the kind of warm red light that an ultra-cool dwarf emits. And in late 2016 it was pointed at TRAPPIST-1 and held there for 20 days without interruption. 20 days of unblinking measurement. No dawn, no clouds, no atmosphere shimmering the signal. Just one dim star and a patient machine and an unbroken line of data pouring back across 150 million kilometers. What came back was not 3 planets, it was 7. The messy third signal resolved into several different worlds passing at different times. Out of that 20-day stare emerged the full family B, C, D, E, F, G, and H, with the outermost one only clearly pinned down after further observation. 7 rocky bodies in a resonance chain, 3 of them in or near the zone where liquid water could survive on a surface. The announcement came in February of 2017. I remember the pictures the artists made, the imagined red skies, the imagined shorelines. I remember how strange it was to have a star that had been an unremarkable smudge in a catalog suddenly become somewhere, a location with rooms in it, a place you could point at. And here is the part of the story I keep coming back to at this hour of the night. A 60-centimeter telescope. A team of a few dozen people, a star nobody had bothered with, in a constellation nobody looks at, because it was too dim to be interesting. The whole thing rested on somebody deciding that the overlooked category was worth the effort, and then on years of unglamorous, repetitive, largely uneventful watching. There was no single moment of revelation. There was a slow accumulation of small confirmations until the shape of something became undeniable. I think that is how most true things arrive. Not as a flash, as a pattern that shows up often enough that you finally trust it. Once the 7 were known, a second kind of work began, and it is one of the most beautiful pieces of indirect reasoning we have ever pulled off. So let me lay it out for you, because it will explain how anyone can claim to know what a rock 40 light-years away is made of. When a planet crosses its star, the timing of that crossing should be perfectly regular if the planet is alone. Around and around, the same interval, forever. But these planets are not alone, and they are packed close, so each one tugs at its neighbors. The tug slightly speeds up one crossing and slightly delays another. The transits arrive early by a few seconds, then late by a few seconds, in a pattern that repeats over months. Those few seconds carry the masses. If you measure precisely when each planet arrives, and you build a model of 7 bodies pulling on each other, and you adjust the masses in the model until the predicted arrival times match the observed ones, then the masses that make it fit are the real masses. Nobody has weighed those planets on a scale. We inferred their weights from the fact that they are slightly impatient with each other. And once you have the mass, and you already have the size from how much light each one blocks, you have the density. And density tells you what a thing is made of in the crudest and most reliable way. Iron is dense. Rock is less dense. Water is much less dense. Gas is barely there at all. The densities that came out of that analysis said, these are rocky worlds, comparable to Earth in size and in bulk composition. Several of them are somewhat less dense than Earth, which likely means they hold a larger fraction of lighter material, possibly water, in ice or in ocean, or bound into their minerals, and quite possibly in amounts that dwarf all the water on our planet. Consider what has just happened in that sentence. Somebody in Chile watched a faint red dot flicker. Somebody in orbit watched the same dot for 20 days. Somebody at a desk noticed that the flickers were arriving a few seconds off schedule, and out of that came a claim about how much water there might be under the surface of a world 385 trillion kilometers from the desk. We did not go there. We have never sent anything in that direction. We simply paid very close attention to a small amount of light for a long time and refused to round anything off. More recently, the James Webb Space Telescope has taken up the work, and it is doing something even finer. When a planet with an atmosphere crosses in front of its star, a sliver of starlight passes through that atmosphere on its way to us, and the gases in it absorb particular colors, leaving gaps in the spectrum like missing teeth. Read the gaps, and you read the air. Webb has looked hard at the two innermost worlds, and what it has found so far is an absence. No evidence of thick atmospheres on those two, which is honest and unsurprising, since they are the closest to the star and the most exposed. The outer worlds, the ones in the temperate ring, are harder targets, and the work is ongoing. We may not have a clear answer for years yet. I want to be straightforward with you about that rather than sell you a fantasy, because the truth is more restful than the fantasy anyway. We do not know if anything is alive there. We do not know if there is air. There is a real possibility that these are 7 bare stones under a red light. No oceans, no clouds, nothing but rock and dust, and the long unmoving day. And that would be fine. It would not make the resonance chain less remarkable. It would not make the star's 12 trillion year patience less consoling. It would not mean the watching was wasted. The universe is not obliged to be populated in order to be worth attention. Most of it is empty, and it is still the most interesting thing there is. Whatever is or is not on those surfaces, they are there tonight, turning once per orbit, holding their faces to the ember, passing in front of one another in the dark, while you lie here with your eyes closed. Now let us go back to the question in the title and start counting. 385 trillion kilometers. Let us cross it, slowly, in everything we have. Start with your own body, because that is the measure everything else is compared against. A person walking at a comfortable pace covers about 5 kilometers in an hour. Walk without stopping, without sleeping, without eating, straight through the vacuum as though it were a road, and you would arrive at TRAPPIST-1 in a little under 9 billion years. That is longer than the Earth has existed. That is longer than the Sun has existed. You would set out, and the Sun would swell into a red giant and swallow Mercury and Venus and scorch the Earth to bare rock, and you would keep walking, and the Sun would shed its outer layers into a glowing shell and shrink to a white cinder, and you would keep walking, and you would still have several billion years of walking left to do. That is the scale we are working with. Everything after this is an improvement on 9 billion years. Put yourself in a car, 100 kilometers an hour on a straight highway with nothing in front of you. 20 times faster than walking, which drops the trip to about 440 million years. 440 million years ago on this planet, the land was almost empty. There were no trees, no insects with wings, no animals with backbones on the ground. The first small plants were just beginning to grip the edges of the water. Set out in the car at that moment, drive continuously at highway speed through every subsequent event in the history of life on this world, through the rise of forests and the coal swamps and the great extinctions and the dinosaurs and the mammals and the whole of human history, and you would be arriving about now. Get on a passenger jet. 900 kilometers an hour, cruising above the weather with the cabin lights dimmed and a plastic cup of water on the tray. 49 million years. 50 million years ago, the early relatives of horses were the size of a small dog, and the ancestors of whales were still walking on riverbanks on 4 legs. Board the plane then, cross the whole Cenozoic at cruising altitude, and you are landing tonight. Take a rifle bullet, about 1 kilometer per second, which is fast enough that you would not see it. It would take roughly 12 million years. Now leave the atmosphere and start using real spacecraft numbers, because this is where the improvements get serious and, in a way, where they stop getting serious enough. The Apollo capsules coming back from the moon were among the fastest crewed objects ever, hitting around 11 kilometers per second on re-entry, close to 40,000 kilometers an hour. At that speed, straight line, no stopping, the trip to TRAPPIST-1 takes about 1,100,000 years. 1 million years ago, there were no people like us on this planet. Our ancestors were making stone tools and had not yet learned to control fire reliably. Load them into an Apollo capsule at that moment, and the capsule would be arriving now, with everything that has ever been thought and said and built by our species having happened during the flight. And not one of those events would have made the slightest difference to the capsule's progress, which would have continued at exactly the same speed the whole time without anyone touching a control. There is the coast again. Notice how it works. The capsule does not get tired at year 400,000. It does not need refueling. It does not slow. The universe simply carries it at the speed it was given once, forever. The New Horizons probe, which flew past Pluto in 2015, left Earth faster than anything before it and cruises at about 16 kilometers per second. Voyager 1, launched in 1977 and now the most distant human-made object, moves at about 17 kilometers per second relative to the Sun, having been slung faster by close passes at Jupiter and Saturn. 17 kilometers per second is 61,000 kilometers an hour. It is a genuinely enormous speed by every standard of ordinary human life. It would take you from London to New York in about 5 minutes. At Voyager's speed, TRAPPIST-1 is about 717,000 years away. 700,000 years. Let me hang some things on that number so it has weight. 700,000 years ago, our species did not exist. The Sahara has been a desert and a grassland and a desert again several times over in that span. Ice sheets have advanced across northern continents and retreated and advanced again, 7 or 8 full cycles of them. Every language now spoken on Earth was born and will die inside that window many times over. And Voyager, if you pointed it that way, would just be arriving. It is worth dwelling on what Voyager actually is right now, tonight, because it is the closest thing we have to the experience we are describing. It launched before most people listening to this were born. Its instruments were designed with the technology of the early 1970s. Its computers have a few thousand words of memory, less than a modern greeting card that plays a tune. It has left the region where the sun's wind dominates and is now moving through the material between stars. It runs on the warmth of decaying plutonium, and that warmth is fading. And within the next few years, the last instrument will be switched off, and it will go dark and silent. And then it will keep going. That is the part that undoes me. When the last watt is gone and the last signal has faded and nobody on Earth can hear it anymore, nothing about its motion changes. It does not drift to a halt. It does not need us. It coasts at 17 kilometers per second through a medium so thin that in 1,000,000 years it might sweep up a few grams of matter. It will outlast the transmitter, the engineers, the agency, the language the instructions were written in, and very probably the species. It is the longest lasting artifact we have ever made, and we made it by accident, simply by throwing something hard enough in a place with nothing to stop it. There is a phonograph record bolted to its side, gold-plated, with greetings in 55 languages and the sound of a kiss and a mother's first words to her child and whale song and Bach and thunder. It was not put there because anyone seriously expected it to be found. It was put there because when you send something out that will outlive everything, you want it to be carrying something worth carrying. Now let us go faster. Much faster. The fastest thing we have ever built is the Parker Solar Probe, and it did not get its speed from engines. It got it from falling. It dives repeatedly toward the Sun, using close passes at Venus to tighten its orbit, and at its closest approach, it whips around the Sun at nearly 700,000 kilometers an hour, around 190 kilometers every second. It is, at that instant, moving faster than any object humans have ever accelerated. Take that speed and turn it toward Aquarius, and the trip becomes about 63,000 years. 63,000 years. It is the first number tonight that touches human history at all, and only barely. 60,000 years ago, people were painting on cave walls in Europe and Indonesia, crossing water to reach Australia, wearing shells as ornaments, burying their dead with care. Set out from those caves at Parker Solar Probe speed, and you would be arriving in this decade. Everything since the first painted handprint would have happened during your coast. And that is our record. That is the fastest we have ever moved anything, and it still turns the journey into a span longer than every human civilization stacked end to end. I want to be honest about why, because the reason is not lack of ambition. The reason is arithmetic. A rocket works by throwing mass out the back. The speed you can reach depends on how fast you throw it and on the ratio of your starting mass to your final mass, and that relationship is not linear. It is logarithmic, which is a mathematical way of saying it becomes cruel very quickly. To go twice as fast, you do not need twice the fuel. You need the fuel squared. Chemical fuels release energy from rearranging electrons in molecules, which is a small amount of energy per kilogram, which caps the exhaust speed at around 4 or 5 kilometers per second. To reach even 1% of light speed with chemical rockets, the fuel required exceeds the mass of the observable universe by a margin that makes the calculation meaningless. So we cannot get there this way. Not with fire. Not with anything we burn. But before we move on to the ideas that might work, I want to sit inside this section of the journey with you for a while, because there is something here worth more than the numbers. Imagine you are aboard. Not launching. Not arriving. Simply aboard, mid-coast, somewhere out in the enormous middle of it. The engines have been dead for a very long time. There is no vibration. Because there is nothing pushing, there is no sound. Because sound needs air, and there is none outside, and the air inside is entirely undisturbed. You are not falling, and you are not being pressed into a seat. You are simply floating, held nowhere, resting on nothing, with your arms drifting a little away from your body, in the position they naturally take when no muscle is holding them. Elbows bent, fingers half curled, the posture that every astronaut adopts in their sleep, whether they mean to or not. Outside the window, the view does not change. That is the part nobody prepares you for. You are moving faster than any human has ever moved, and nothing appears to move at all. The stars are so far away that even at enormous speed their positions shift imperceptibly. A whole year passes, and the constellations look the same. A century passes, and only the very nearest stars have crept a finger's width. The window shows you a scene that could be a photograph and would remain indistinguishable from a photograph for the entire duration of a human life. So there is no sense of speed. There is no rushing. There is no wind, no engine note, no landscape peeling past. There is only a dark field of unmoving lights and a small warm room, and behind you, somewhere in that field, a dim yellow point that used to be your sun, and ahead, somewhere in the other direction, a red point too faint to pick out. You could sleep the entire way and arrive on schedule. That is the strangest and gentlest fact of interstellar travel. Vigilance adds nothing. Effort adds nothing. Once the burn is over, the trip is entirely out of your hands, and it does not need your hands. The ship holds its speed because the universe has nothing to take it away with. Let that shape your breathing for a moment. You are not being asked to push. You are being carried. Everything necessary has already been done somewhere far behind you by people who are no longer awake, and what remains is not work. What remains is duration. Now the dreamed engines, the ones on paper, the ones that might one day turn 700,000 years into something a civilization could keep faith with. The first idea, and the oldest, is to stop carrying your fuel. This is the fundamental trap of the rocket. Everything you burn at the end of the trip had to be lifted and accelerated at the beginning, so most of your effort goes into moving the fuel that will later move you. It is like a runner who must carry every meal they will eat for a year. The way out is to be pushed from outside. Light can push. This is not metaphor, and it is not speculation. It is measured, everyday physics. Light has no mass, but it carries momentum, and when it strikes a surface and bounces off, it hands over a tiny amount of that momentum. The push is minuscule. Sunlight falling on a square kilometer of perfectly reflective surface near the Earth exerts about the force of a paperclip lying in your palm. But in vacuum, with nothing pushing back, a force that never stops adds up without limit. A paperclip's worth of push, applied for a month, then a year, then a decade, becomes real speed. We have already flown these. A Japanese spacecraft called Icaros unfurled a sail and rode sunlight past Venus. A small craft called LightSail 2, funded by public donations, raised its orbit around the Earth using nothing but photons. The principle is proven. A sail works. Sunlight alone thins out too quickly to get you to another star, so the serious proposals replace the sun with a laser. Build an array of lasers on the ground or in orbit, aim them at a departing sail, and pour energy into it for as long as it remains in range. The craft carries no fuel at all. It carries only a mirror and whatever you have attached to it. The most developed version of this idea imagines something very small, not a ship, a chip. A gram of electronics, camera and transmitter and power supply, riding on a sail a few meters across and thinner than a soap bubble, accelerated by an enormous laser array for a few minutes to about 20% of the speed of light. 20% of light speed. 60,000 kilometers every second. At that speed, TRAPPIST-1 is about 204 years away. 200 years. That is a number a civilization can hold. That is the age of some of the buildings in your city. That is 4 or 5 generations, a length of time over which families continue, and institutions persist, and archives are kept. You could launch it, and your great-great-grandchildren could be the ones watching for the signal to come back 40 more years after that, and they would know exactly which night to look, because you would have told them, and they would have told their children. I find that a beautiful shape for a project, something begun by people who will never see it end, maintained by people who did not begin it, completed by people who never met either. Of course, there are difficulties, and I will lay them out because they are more interesting than the fantasy. A sail traveling at 20% of light speed cannot stop. It has no fuel to slow down with. It would tear through the TRAPPIST-1 system in a matter of hours, taking whatever images it could as the 7 worlds flashed past, and then continue out the other side forever. A 200-year voyage for an afternoon's data. And that data would then take 40 more years to crawl home as a whisper of radio from a gram-sized transmitter. There are ways around this. Some designs propose using the destination star's own light and magnetic environment as a brake, spreading the sail wide and letting the oncoming photons and particles push back to shed speed. It works better around a bright star than a dim ember like TRAPPIST-1, which does not have much light to break with. Others accept the flyby and simply send many craft, 100, 1,000, launched a week apart, arriving a week apart, each one contributing a fragment of a picture, the way a long exposure builds an image out of individual photons. Then there is the dust. Between the stars, space is not perfectly empty. There are grains, most of them smaller than the width of a human hair, spread with unimaginable sparseness. At walking pace, they are nothing. At 60,000 kilometers per second, a grain of dust carries the energy of a small explosion. Over 40 light years, a sail would meet a great many of them. The proposed answer is elegant and rather moving. Make the craft so small and so cheap that losing most of them does not matter. Send thousands. Accept that the interstellar medium will erode them. Design for attrition instead of armor. It is the strategy of a dandelion rather than an oak, and the galaxy, being mostly empty and mostly hostile, probably rewards dandelions. Now the other family of ideas, the ones that involve carrying an engine after all, but a far better one. Fusion, the same reaction that powers the star we are traveling toward, and every other star. Press hydrogen nuclei together hard enough, and they merge into helium, releasing energy from the mass difference. And the energy per kilogram is roughly 1,000,000 times what you get from chemical burning. If you could run that reaction in a controlled way and throw the products out the back, exhaust speeds jump from 4 kilometers per second to thousands. Serious engineering studies have been done on this. In the 1970s, a group of British engineers spent 5 years designing an unmanned fusion-powered probe intended to reach a nearby star within a human working lifetime. They did it in the evenings, unpaid, meeting in a room above a pub in London. Their design was a 2-stage vessel the size of a large building, burning a rare isotope of helium that they proposed to mine from the atmosphere of Jupiter with floating factories, and it would have reached about 12% of light speed. At 12% of light speed, TRAPPIST-1 is about 340 years away. The design was never built and was never expected to be. The point of the exercise was to demonstrate that an interstellar probe was not a violation of physics, only of budgets, and that a group of people with slide rules and evenings free could show the way. I love that the most credible starship design of the 20th century was drawn up by volunteers in a pub. It suggests something about where long projects actually come from. Not from urgency, from devotion. Then there is the option that is almost certainly the most efficient thing physics permits, and also the most difficult: antimatter. Every particle has a mirror partner with opposite charge, and when the two meet, they do not partly react. They annihilate completely, converting all of their mass into energy, not a fraction of a percent, as in fission, not a fraction of a percent, as in fusion. All of it. A single gram of antimatter meeting a gram of matter releases energy comparable to a large nuclear weapon. An antimatter rocket could, in principle, reach a substantial fraction of light speed with a manageable amount of propellant. The catch is that antimatter does not occur naturally in any useful quantity. We make it in particle accelerators, a few atoms at a time, at a cost that makes it the most expensive substance in existence by an absurd margin. The total amount ever produced by humanity, if gathered together, would weigh less than a grain of sand and would not power a light bulb for long. And you cannot store it in a container because it would annihilate the container. It must be held in magnetic traps, in vacuum, touching nothing. So, possible in principle, impossible in practice, for now. Which is where nearly everything on this list sat 200 years ago, including the aeroplane. And there is one more, older and cruder and strangely plausible: ride the explosions. In the 1950s and 60s, a project in the United States studied a spacecraft propelled by detonating nuclear devices behind a heavy pusher plate, one after another, riding the shockwaves. The physics works. The engineering was studied seriously by people who knew what they were doing, and they concluded that such a ship could reach a few percent of light speed and could be large. Not a chip on a sail, but a vessel with rooms in it and people inside. It was abandoned for excellent reasons, chief among them the treaty banning nuclear detonations in space and the obvious problem of launching such a thing from a planet where people live. But it remains the only design ever seriously studied that could have moved something large and crewed between stars using technology that already existed. At a few percent of light speed, TRAPPIST-1 is something like 10,000 years away, which brings us, unavoidably, to the ship that does not try to be fast. If you cannot shorten the journey, you can lengthen the traveler, not by extending a life, but by handing the journey down. A generation ship is a vessel built to be a world rather than a vehicle, enclosed, self-sustaining, with soil and water and air cycling through it, with people living whole lives inside, being born, growing, working, aging and dying, and their children doing the same, and their children, for as long as the crossing takes. Nobody who boards ever arrives. Nobody who arrives ever boarded. The ship is a place, and the destination is an inheritance. Studies of what such a thing would require have grown more careful over the years. You need a population large enough to remain genetically healthy across many generations, and the estimates have ranged from a few hundred to a few thousand, with modern analyses converging on the low thousands to be safe. You need an ecosystem that recycles everything, every breath of carbon dioxide back into oxygen through plants, every drop of water through soil and vapor and rain, every gram of waste back into growth. You need redundancy in every system, because there is no port to put in at, and you need something much harder than any of that: a culture that can transmit purpose across 20 generations without either abandoning it or turning it into a rigid faith. That last problem is the real one, and it is not an engineering problem. It is the same problem as building a cathedral over 3 centuries, or maintaining a monastery, or keeping an oral tradition intact across 100 lifetimes. Human beings have done this, not often and not reliably, but we have done it. There are institutions on this planet, older than most nations, kept alive by nothing but people teaching people what matters. At the speeds that seem achievable for something so massive, a few % of light, a generation ship reaches TRAPPIST-1 in somewhere between 1,000 and 10,000 years, between 40 and 400 generations. A number of human lives comparable to the entire span from the first cities to now, and the whole time, remember what is actually happening out there. Not struggle, not a chase, nothing but the coast. The ship keeps its speed without being asked. Whole dynasties are born and buried inside a vessel that is doing nothing at all except continuing exactly as it was set going, by people whose names have long since become legend, and then footnote, and then nothing. There is one more way to shorten the journey, and it is the strangest of all, because it does not shorten the distance or increase the speed. It shortens you. Nothing with mass can reach the speed of light. That is not a technological limit, it is structural. The closer you get, the more energy each additional increment demands, and the demand climbs toward infinity as you approach the edge. Light itself gets to go at light speed only because it has no mass to drag along. But you can get close. 90%. 99. 99.9. And as you do, something happens that is not an illusion and not a trick of perspective, but a real feature of how space and time are joined. Time, for you, passes more slowly than for those you left behind. Not seemingly. Actually, we have measured this. We have flown atomic clocks around the world on commercial airliners and brought them back running fractionally behind their twins that stayed on the ground. We correct for it constantly in the satellites that tell your phone where it is, without accounting for the different rate at which time runs up there. The positioning would drift by kilometers within a day. We see it in unstable particles created in the upper atmosphere that should decay long before reaching the ground, and which reach the ground anyway, because at their speed their internal clocks are running slow enough to survive the fall. This is one of the best tested statements in all of physics. So take the journey at 99% of light speed. From the perspective of anyone watching from Earth, it takes a little over 41 years, because you are covering 40.7 light years at very nearly the speed of light, and cannot do better than that. But aboard the ship, the clocks run slow by a factor of about 7. The crossing takes not 41 years, but about 5 years and 10 months. Push it further to 99.9%, and the factor becomes about 22. 41 years outside, under 2 years inside. Push to 99.99%, and the traveler crosses 40 light years in a bit over 7 months of lived time. And it is not merely that your clock runs slow. From your seat, the universe itself changes shape. Space in the direction of travel contracts. You do not experience yourself as crawling, you experience the distance as having shrunk. The 40.7 light years genuinely, measurably, is a shorter distance in your reference frame. Both descriptions are correct. There is no privileged one. The universe simply does not have a single shared answer to how far apart two things are, and it never did, and we only failed to notice because we have spent our whole history moving so slowly that the discrepancy hides in the 18th decimal place. Now, the accounting. Nobody would actually make such a trip at constant speed, because getting to 99% of light speed instantly would flatten a crew against the back wall. The realistic version is to accelerate steadily. Suppose you build a ship that can accelerate at 1 g, exactly the pull you feel lying in your bed right now, the force holding you against the mattress. Run that acceleration for the first half of the trip, then turn the ship around and decelerate at the same rate for the second half, so you arrive at rest instead of tearing through at near light speed. Everyone aboard has normal weight the entire way. Floors and ceilings behave. Water pours downward into a glass. Do the mathematics of that, and something wonderful falls out. Under continuous 1 g acceleration and deceleration, the trip to TRAPPIST-1 takes about 43 years as measured on Earth, and about 7 years and 4 months as measured by the people aboard. 7 years. A person could board in their 20s and step out onto a red-lit world in their early 30s. They could raise a child on the way, and that child would be old enough to remember the arrival. This is not fringe speculation. It is straightforward relativistic kinematics, worked out from equations that have been checked to extraordinary precision. The only thing standing between us, and it is the energy, which is preposterous. Roughly the entire lifetime output of a large nation for a single ship, and there is no known way to carry or collect it. But the physics does not object. Only the engineering does. And here is the ache inside that arithmetic, which I want to hand you carefully because it is beautiful rather than sad. The traveler who takes 7 years to get there returns, if they turn around immediately, to an Earth that has aged about 86 years. Everyone they knew is gone or very old. Their friends' grandchildren are middle-aged. The city has been rebuilt twice. The traveler comes home young to a world that has moved on without them, carrying 7 years of memory into a place that has lived through nearly a century. This is not a paradox, and it is not a punishment. It is simply what it means for time to be a dimension you move through at an angle, rather than a river that carries everyone at the same rate. Two people can leave the same point and arrive at the same point having experienced different amounts of duration. In the same way, two people can drive from one city to another by different roads and have different numbers on their odometers. Nobody is wrong. Nobody was cheated. The distances traveled through time were simply not the same. I think there is something in this that speaks to the ordinary experience of being alive, and I offer it only as a thought to drift on. You have already noticed that time does not pass at one rate for you. An afternoon in a waiting room and an afternoon with someone you love are not the same length, whatever the clock says. A year in which nothing changes compresses in memory to almost nothing. A year of upheaval expands into what feels like a decade. We have always known, in our bodies, that duration is not a fixed public quantity. Physics agreed with us more literally than we expected. So when I say the journey to TRAPPIST-1 takes 41 years or 700,000 years, understand that I am not describing one fact. I am describing an answer that depends entirely on who is being asked, and where they are standing, and how fast they are going. The question in the title, "How long would it take?" has no single answer. It has a family of answers, all true at once, none of them competing. For light, 40.7 years. For a traveler at 99% of light speed, under 6 years. For a ship at 1 g, about 7 years and 4 months, arriving intact. For a laser-driven sail, about 2 centuries. For a fusion probe, a bit over 3. For a generation ship, 1,000 years and upward. For our fastest existing machine, 63,000. For Voyager, 700,000. For someone walking, 9 billion. Every one of those is the correct duration for the thing doing the traveling. Nothing about the distance changed between them. Only the traveler. There is a quieter version of this that applies directly to the pillow under your head. You are, at this moment, traveling. The Earth is turning beneath you at several hundred meters per second at most latitudes, carrying your bed east through the dark. The Earth is also going around the Sun at about 30 kilometers per second, so in the time it takes you to exhale, you have moved 150 kilometers along your orbit. The Sun is carrying the whole system around the center of the galaxy at about 230 kilometers per second, a circuit that takes something like 230 million years to complete, which means the last time our Sun was in this part of its orbit, the first dinosaurs were appearing. And the galaxy itself is moving with respect to the ancient background glow of the universe at hundreds of kilometers per second. Add all that up, and you are, right now, lying motionless in a bed, moving at something like 600 kilometers per second with respect to the oldest light there is. You cannot feel any of it. Not 1 meter of it. Because motion at constant velocity is undetectable from the inside, there is no experiment you can do in a sealed room to determine how fast you are going, only how fast you are changing. This is the oldest and deepest principle in the whole subject, older than relativity. Going back to Galileo, watching insects fly around a cabin below decks on a moving ship, and noticing that they flew exactly as they did in port. So you are already coasting. You have been coasting your whole life. Every night you have ever slept, you have slept aboard a moving object, with no engine running, carried at enormous speed through a dark that offers no resistance, arriving nowhere in particular, on a trajectory set long before you were born by processes nobody supervises. If that is not proof that a journey can be a form of rest, I do not know what would be. Now let me put you inside the crossing itself, in the fullest way I can, and then we will come back and talk about what it all means. Let your body come to a complete stop for a moment. Not asleep yet, only paused. Let the weight of you settle down into whatever is holding you, and notice that you are not holding yourself up at all. The mattress is doing it. The floor is doing it. The building is doing it. The ground beneath the building is doing it, and it has been doing it, without complaint, without your attention, for every second of your life. Now let the room go, and let yourself be aboard. You are in a small chamber somewhere in the middle of a very long crossing. The lights have been dimmed on a schedule set by people who are not on board anymore. The air moves past your face with the faintest current, warm, recycled, faintly green smelling from the growing racks 2 decks away, and it moves because a fan somewhere has been turning at the same speed for a very long time and will keep turning. There is a low sound underneath everything, so constant that the ear stopped reporting it years ago. Pumps, circulation, the machinery of a place that keeps itself. You are weightless, or nearly so, held by a single strap across the hips so you do not drift into a wall while you sleep. Your arms have floated up in front of you into that half curl. Your spine has lengthened, the way spines do without weight, so you are a fraction taller than you were on the ground, and your back does not ache in the places it used to. Through the small window, unchanged since the last time you looked, and unchanged since the time before that, there is the field of stars, absolutely fixed, absolutely patient. Ahead somewhere, too dim to identify without instruments, an ember. Behind, another one. And nothing is being asked of you. Not by the ship, which needs no steering, Not by the vacuum, which offers no resistance. Not by the destination, which is not expecting anyone and will not be disappointed. Not by the people who launched this, all of whom are long past caring. The crossing does not require your attention to continue. It would continue in exactly the same way if every person aboard slept for 100 years. That is the deepest fact of interstellar travel, and the one I most want you to take with you into sleep. The journey continues without effort. The distance is being crossed at this instant, whether or not anyone is awake to notice, whether or not anyone remembers why. Rest is not a pause in the journey. Out here, rest is the journey. They are the same activity. Let us consider, then, the traveler that has already made the trip, many times, in both directions, without effort, without fuel, without anyone building anything. Light, tonight, if you were outside under a properly dark sky and you knew exactly where to look in Aquarius, and you had a telescope of reasonable size, you could gather photons that left TRAPPIST-1 about 40.7 years ago. They departed that red surface, crossed the whole of the distance we have spent this hour describing, passed through your window or your telescope's mirror, and ended their existence in the back of your eye, absorbed by a molecule in a cell, converted into a signal, delivered to your brain as a faint red point. That light left in the middle of the 1980s. Think about what you were doing then, if you were anything at all. Think about what the world was doing. Those photons set out while people were listening to music on cassettes, before most of the technology in your house existed, before the internet was anything but a research curiosity, before a great many of the people you love were born. They have been traveling ever since, through absolutely nothing, at the maximum permitted speed, in a perfectly straight line, and they finished their journey tonight in the back of somebody's eye. And here is the odd and wonderful thing about that traveler. From light's own point of view, if we can even use such a phrase, no time passed at all. At exactly the speed of light, the time dilation factor becomes infinite. Duration collapses to zero. The photon that left TRAPPIST-1 in 1985 and arrives tonight experienced, in whatever sense is available to it, no interval whatsoever between emission and absorption. Departure and arrival are the same event. 40.7 light years of distance, 40.7 years of our waiting, and for the thing crossing it, nothing at all. Not a long trip, not a short trip, no trip. I do not know what to do with that fact except hold it. Every beam of light that has ever reached you, from the sun, from a lamp, from the face of someone across a room, arrived without any passage of time for itself. From light's perspective, the universe has no distances in it. Everything touches everything. All the separations we have spent tonight measuring exist only for slow, heavy things like us. We are the ones for whom there is far. Light does not have far. So the fastest way to get to TRAPPIST-1 is to not go, to send instead. To become, briefly, the kind of thing that has no distances. That is the basis of every serious proposal to make contact rather than to travel. A radio signal is light of a longer wavelength. It goes at the same speed. It costs almost nothing to send compared to a ship, and it arrives in 40.7 years. If somebody transmitted tonight, aimed carefully, the signal would reach that system in the 2060s. If anything were there to answer, and answered immediately, the reply would come back in the 2000s. 81 years for one exchange, one question and one answer, and 4 generations to hear both. Imagine what a conversation like that would be. You could not converse at all in the way we mean. You would speak into the dark, knowing that no answer could exist within your lifetime. And if you had children, They might live to see the reply arrive, or their children would. Every sentence would have to be a complete message, self-contained, needing no clarification, because clarification takes 81 years. You would have to say the thing you actually meant on the first attempt. I sometimes think that would improve us. To speak, knowing the answer belongs to someone else, and to answer knowing the question came from someone gone. That is what a letter to the future is. That is what every archive is, every recorded voice, every building meant to outlast its architect. We are more practiced at it than we think. And in the other direction, the light coming toward us right now, tonight from that system, carries genuine information. That is not sentiment. That is the entire basis of the science we have been discussing. Every fact we know about those 7 worlds arrived in the form of light, and the light was not sent to us, and nothing intended us to have it, and we read it anyway. Consider the trick with the atmospheres once more, because it is worth admiring slowly. When one of those planets crosses in front of its star, most of the starlight we receive comes straight from the disk. But a thin ring of it grazes the very edge of the planet, passing through whatever atmosphere might be there. A few tens of kilometers of gas at most, before continuing on for 40 light years. In that brief passage through that thin shell, particular molecules absorb particular colors. Carbon dioxide takes a bite here. Water vapor takes one there. Methane, oxygen, ozone. Each one leaves a characteristic pattern of absence. So the light arrives at the mirror of a telescope 1.5 million kilometers from Earth, carrying, encoded as gaps in a spectrum, a description of the air on a world 40 light years away, imprinted on it by a grazing pass through a layer thinner than the skin of a grape, 4 decades ago. And we can read it. We built a machine that can read it. Not perfectly, not yet for the small temperate worlds, but the method works, and the instrument exists, and it is out there tonight, unfolded, cold, held at a point of gravitational balance, staring. That is how the answer will come. If it comes. Not from a ship, not from an arrival. From a patient instrument reading the faint fingerprints in light that left before anyone alive was watching for it. There is a version of this that is even more startling, and it works in the opposite direction. If someone on one of those 7 worlds had a telescope like ours and pointed it at our sun tonight, they would not see us. They would see the light that left here 40.7 years ago. They would be watching the 1980s. And if their instruments were fine enough to catch the Earth crossing in front of the sun, they could read our atmosphere the same way we read theirs, and they would find oxygen where oxygen has no business being, because oxygen is so reactive that it disappears within a few million years unless something keeps making it. They would find methane alongside it, which should not coexist with oxygen for long. And they would have, in that combination of colors missing from our starlight, strong evidence that something on this planet is alive. They would not know what. They would not know about us specifically. They would know only that the third rock from that yellow star has an atmosphere that cannot explain itself. And we would have no idea they were looking. We would be doing whatever we were doing in 1985, entirely unaware, our light already 40 years gone. Both of us, in that scenario, looking at each other's pasts, unable to wave, unable to check, doing the best possible science on the only thing that ever crosses the gap. I find that image restful rather than lonely, and I want to say why. We tend to think of distance as separation, as a failure, as something to be overcome. But what the light actually establishes is a kind of contact that does not require crossing anything. That star is not cut off from us, it is touching us, tonight, with the only part of itself that can travel. The photons currently entering the atmosphere above your house from Aquarius are as much a piece of that star as anything in it. Some tiny number of them will land on the roof over your head while you sleep. You are being rained on, faintly, by a star with 7 worlds. And it has been going on your whole life, and you have never once had to be awake for it. We should acknowledge the harder facts too, briefly and without drama, because I promised you honesty, and because the honest version is not frightening. Small red stars are not entirely placid. They have strong magnetic fields, they are fully churning, and they can flare, releasing bursts of radiation far larger in proportion to their normal output than anything our sun does. A world sitting very close to such a star, without a strong magnetic field of its own, could have its atmosphere stripped away over hundreds of millions of years. That is one of the leading reasons for doubting whether those 7 worlds hold on to air, and it is why the results from the innermost 2, showing no thick atmosphere, were not a surprise. But hold the shape of it properly. This is not violence. A star flaring is a star doing the ordinary thing that stars do when magnetic field lines under their surface twist past the point of holding and snap into a simpler arrangement, releasing stored energy. It is the same process that makes the aurora dance above the poles of this planet. It is a rearrangement, not an attack. And it happens over spans of time so long that nothing on any of those surfaces would experience it as sudden. Nothing out there is trying to do anything. There is no hostility in the vacuum. The dust that would erode a sail is not aiming. The radiation that might strip an atmosphere is not hunting. The distance that defeats our rockets is not withholding. There is no adversary in this story at all, and I think that is the single most calming feature of astronomy. Everything difficult about reaching TRAPPIST-1 is difficult in the way that a mountain is tall, impersonally, indifferently, without malice, and without judgment of anyone who does not climb it. The universe is not hard on you, it is simply large. Which brings us to the last thing I want to lay beside you before we begin to close, and it is the part that has nothing to do with engines. Suppose we could go. Suppose the sails were built, and the lasers fired, and the first probe crossed in 200 years, and the first crewed vessel followed after. What would it be for? Not resources. There is nothing in that system worth the energy of fetching, and there never will be. Anything you could mine there exists in abundance in our own asteroid belt at a fraction of the cost. Not escape, either. Whatever we might do to this planet, it would remain vastly more habitable than a tidally locked rock under a red star, and the effort required to make that rock livable would always be less than the effort required to repair what we have. Nobody is going to TRAPPIST-1 to survive. The honest answer is that we would go for the same reason we watched. Because it is there, and we are the kind of creature that looks. And this is where the length of the journey stops being an obstacle and becomes, I think, the whole point. There is a category of human project that only makes sense if you accept that you will not see the end of it. Planting a walnut grove that will not bear well for 40 years. Beginning a cathedral whose spire your great-grandchildren will finish. Copying a manuscript by hand in a cold room so that a text survives a century you will not live in. Building a seed vault into a mountainside for a famine that may not come for 1,000 years. setting up a research program to measure something that will only become clear after 3 generations of measurement. We are peculiarly capable of this, and it is one of the better things about us. We can be motivated by outcomes we will never experience. We can work carefully for the benefit of strangers who do not exist yet and who will not know our names. No other behavior of ours is as strange or as redeeming. An interstellar voyage is that instinct taken to its furthest reach. It is the most extreme act of trust in the future that a species could perform, to spend enormous effort launching something that cannot report back for centuries on behalf of people who will inherit only the waiting. And notice how that reframes the numbers we have spent all this time on. 700,000 years at Voyager's speed sounds like a defeat if you imagine one person trying to endure it. It sounds like something else entirely if you understand that nobody has to endure it. The ship does the duration. That is what a ship is for. The people only ever do their own small piece, the ones who build, the ones who launch, the ones who maintain the archive, the ones who remember to look up on the appointed night 400 years later. Each of those tasks is a human size. None of them is a lifetime of strain. The vast, inhuman remainder is absorbed by the coast, which requires nothing from anyone. This is, I would say without pushing it too hard, roughly how a life works as well. You are not asked to cross your whole distance tonight. You are asked for tonight. The rest of it continues on its own momentum, carried by everything already set in motion, by habits and relationships and work already begun, by the accumulated push of every previous day. Whatever you are traveling toward does not require you to be awake for the middle of the journey. The middle of a journey is not where anything is decided. The middle is where you rest. Let me give you one more image of scale before we begin the descent, and this one is meant to comfort rather than to stagger. We have talked about 40.7 light years as an enormous distance, and by every human measure it is. But hold it against the actual size of things. The disk of our galaxy is about 100,000 light years across. TRAPPIST-1 is 40. On a map of the Milky Way the size of a dinner table, our Sun and TRAPPIST-1 would be 2 specks less than a millimeter apart, closer together than the thickness of a pencil line. They are, in every galactic sense, in the same neighborhood, on the same street, practically in the same house. There are somewhere around 400 billion stars in this galaxy, and TRAPPIST-1 is among the nearest 60 or so systems to us. There are perhaps 2 trillion galaxies in the observable universe, and everything we have discussed tonight fits inside a bubble that would be invisible on any honest map of even one of them. That is not meant to make you feel small. It is meant to make the difficulty feel proportionate. We are not failing to cross a great gulf. We are looking hard at the very closest thing of its kind from the only vantage we have, and we have already learned the masses of 7 stones around it and begun reading their air. For a species that has had telescopes for 400 years and radios for 120, that seems to me an extraordinary rate of progress rather than a failure of reach. And there is something else, which is the last of the facts I want to give you tonight. That star will still be there. This is not a race against a closing door. TRAPPIST-1 has been burning for 7.5 billion years and has trillions ahead of it. If we do not go in this century, or the next, or in the next 10,000 years, it will make no difference to the destination whatsoever. The 7 worlds will be turning in the same resonance, keeping the same 8-5 and 5-3 and 3-2, holding the same faces to the same ember under the same permanent red twilight. Whatever we do or fail to do, whatever happens to this civilization, that arrangement continues. Nothing about it is urgent. Nothing about it can be missed. It is one of the very few things you can be certain of. That place will outlast every deadline you have ever been given. So let the whole question loosen its grip. How long would it take to reach TRAPPIST-1? Longer than any plan. Long enough that the question stops being about arrival and becomes about the quality of the crossing, which is the only part anyone ever actually inhabits, and you are already crossing. Not toward Aquarius, but crossing all the same, carried by a turning planet, on an orbiting star, in a wheeling galaxy, at 600 kilometers a second with respect to the oldest light there is, with no engine, no effort, and no way to feel it. Let yourself be carried now, properly, one more time. And then we will begin to close. Let the muscles of your face let go. The small ones first, the ones around the eyes that hold expression all day without being asked, the ones between the brows that furrow at screens. Let them smooth out. Let the jaw come loose so the teeth are not touching. Let the tongue rest low and wide in the mouth. Let the throat open. Let the shoulders slide down and back, away from the ears, and let the collarbones widen. Let the arms be heavy, not held, not arranged. Heavy, from shoulder to elbow, from elbow to wrist, out into the hands, into the palms, into every finger, until the hands are doing nothing at all. Let the chest go, and let the breathing become smaller and lower, down in the belly, the way it goes on its own when nobody is supervising it. You do not need to breathe deeply. You do not need to breathe in any particular way. Your body has been doing this without instruction since the moment you were born, through every night you have ever slept, and it will keep doing it long after you have stopped paying attention tonight. Let the belly be soft. Let the hips be heavy. Let the legs be heavy, thighs and knees and calves, down into the ankles, into the feet, into the toes, all of it giving its weight to whatever is holding you. And feel the holding, the bed underneath, the floor underneath that, the whole building, the ground, the rock beneath the ground going down for kilometers, the whole mass of a planet turning, carrying you east through the dark at several hundred meters a second, and around a star at 30 kilometers a second, and around a galaxy at 230, and none of it asking anything of you. You are aboard. You have always been aboard. The engine burn happened long before you arrived, and it happened in a place you will never see, and what is left is the coast. Before the last descent, let me give you the arrival, not because anyone will see it, but because you can, tonight, from here, at no cost. Say the crossing is done. Say it took 2 centuries or 10,000 years. It does not matter, because the arrival looks the same either way. The long coast ends, something slows. And the red point that has been indistinguishable from 100 other faint points in the forward window begins, over months, to separate itself, to brighten, to become not a point, but a disk. You come in from above the plane of the system, because that is the sensible approach, and from there the whole architecture is visible at once, which is something you could never do with our own sprawling family of planets. The entire arrangement is smaller than the orbit of Mercury. You could hold the whole system in one field of view, 7 small worlds, going around a coal, and they are moving fast enough that you can watch them move, not over months, over hours. The innermost completes a full year in a day and a half, so you can sit at the window and see it swing all the way around while you eat and sleep and wake. Imagine watching an entire planetary system perform its complete cycle in less time than a fortnight. Every configuration, every alignment, every conjunction, over and over, the 8 to 5 and the 5 to 3 and the 3 to 2, the chords sounding again and again, visible, geometric, repeating like a slow machine made of stone and gravity. Go closer. Fall toward the fourth world, the one in the temperate ring. The light changes as you descend. It reddens further, deepens, until the instruments have to work to render anything in colors a human eye finds natural. The star sits at a fixed point in the sky, and it is huge, several times the width of the sun as seen from Earth, a great dull scarlet coin that never rises and never sets and never moves at all. Below, the day face, whatever it is, rust-colored, unweathered by seasons, holding the same noon it has held for billions of years. Around the limb, the terminator, that seam of permanent dusk running from pole to pole. And beyond it, the night face, which has never once seen the star, lit only by the neighboring worlds when they pass, and they do pass, close and enormous, showing phases, crossing the sky visibly. A companion world hanging there 3 or 4 times the width of our moon, with a lit crescent along one side. Whether there is air there, we do not know. Whether there is water on the surface, or locked as ice on the dark side, or churning in an ocean under a crust, we do not know. Whether anything has ever moved on it under its own power, we do not know. And we may not know in your lifetime or mine. But the light is real. The 7 stones are real. The rhythm they keep is real, and has been measured to the second. And whatever else is or is not true of that place, this much is certain: it is turning right now, exactly as described, while you lie in the dark with your eyes closed on the other side of 385 trillion kilometers of nothing. I want to leave you one last thought about the coast before I begin the closing litany. The reason nothing slows down out there is that there is almost nothing out there. The reason the journey requires no effort is that the space between stars is empty to a degree we have no word for. And the reason the space is empty is that matter has spent 13.5 billion years gathering itself into places, into stars and worlds, and, in at least one location, into people who lie awake at night, wondering how far away things are. Emptiness is not the failure of the universe to be full. It is the consequence of everything having collected somewhere. Every gram of the vacuum's missing material is standing somewhere else, in a star, in a stone, in a body, in the hand resting on the blanket beside you. The great distances exist precisely because things came together. So the gulf between here and TRAPPIST-1 is not a sign of separation. It is the receipt for the gathering. It is what it costs to have places at all. And since we have time, let me tell you where the 7 came from, because the making of them is the same story as the making of you, only earlier. 7.5 billion years ago, before our sun existed, there was a cloud. Cold hydrogen and helium left over from the beginning, seeded with heavier elements manufactured inside earlier stars and scattered outward when those stars ended. Carbon from one, oxygen from another. Iron forged in the last seconds of something enormous. That cloud drifted for an age, doing nothing, held between its own faint gravity and its own faint pressure. And then something disturbed it, a passing shockwave, a neighboring star's death, the slow arm of the galaxy sweeping through, and one region became a fraction denser than the rest. That was enough. Density pulls more density. The dense patch drew in its surroundings, and drawing them in made it denser, and denser made it pull harder, and the collapse fed itself. As it fell inward, it spun faster, the way a turning figure spins faster when the arms come in, and the spin flattened the cloud from a ball into a disk, with a thickening knot at the center. The knot became hot, not from any fire, but from falling, matter surrendering height to gravity and paying for it in heat. Hotter and hotter, and then hot enough at the very core that hydrogen nuclei began to touch and fuse, and light came on inside, and the pressure of that light pushed outward against the collapse and held it. That balance, struck once, has been maintained ever since and will be maintained for trillions of years. That is TRAPPIST-1. Around it, the disk. Dust grains bumping into dust grains at low speeds and sticking, first by static, then by their own weak gravity. Pebbles, boulders, bodies the size of towns, then countries. Out in the cold outer part of that disk, beyond a boundary astronomers call the ice line, water could freeze onto the grains, which gave them more material to work with and made growth faster, which is very likely why these worlds are relatively rich in lighter substances. And then they migrated. Interacting with the remaining gas of the disk, the young planets spiraled inward, and as they came, they caught each other in resonance and locked into step. And the whole family descended together into the tight ring where we find them now. They arrived as a set, in order, in rhythm, and the gas eventually blew away and left them there, holding the formation they had fallen into. Everything about them was assembled from a cloud, by gravity, without design, over hundreds of millions of years, and it has held ever since. The same thing happened here, 2.5 billion years later, in a different cloud. The same collapse, the same disk, the same sticking of grain to grain, the same slow assembly of a world out of debris. The iron in the blood moving through you right now was made in a star that died before the sun was born. The oxygen you are breathing was made the same way. The calcium in your bones, you are, in the most literal chemical sense, the same kind of leftover as those 7 stones, sorted by the same processes into a different arrangement. That is not a poetic flourish. It is inventory. 2 clouds, 2 collapses, 2 families of worlds, 40 light years apart, made of the same elements by the same rules. And in one of them, the material eventually became complicated enough to lie in a bed and wonder about the other. The distance between you and TRAPPIST-1 is enormous. The difference between you and TRAPPIST-1 is almost nothing at all. Let us begin to draw it closed now, unhurriedly, the way a long trip ends, not with a stop, but with a slowing you barely notice. Tonight has been about a question that sounded like arithmetic and turned out to be a lullaby. How long would it take to reach TRAPPIST-1? Tonight has been about a number. 385 trillion kilometers, 40.7 years at the speed of light. A dinner plate here, and another dinner plate 170 kilometers away, with almost nothing in between. Tonight has been about an ember. A star with 9% of the sun's mass and barely more than Jupiter's width, glowing at 2,500 degrees, pouring out 2/1000ths of our sun's light, and holding that same modest output steadily for trillions of years, longer than the age of the universe several hundred times over. Tonight has been about 7 stones. 7 Earth-sized worlds, closer to their star than Mercury is to ours, with years of a day and a half, 2 days, 4, 6, 9, 12, 19, locked to face their star forever. A hemisphere of permanent day, a hemisphere of permanent night, and between them a ring of unmoving dusk running pole to pole. Tonight has been about accord. 8 to 5, 5 to 3, 3 to 2, 3 to 2, 4 to 3, 3 to 2. A resonance chain that has been holding its rhythm since before this planet had oceans and will hold it long after this planet has none. Tonight has been about a 60-centimeter telescope on a dry ridge in Chile, watching dim stars nobody else thought worth watching. About a flat line of numbers that bent, once, by less than 1%. About 20 days of unbroken staring from an infrared telescope in orbit, and 7 worlds emerging out of the tangle. Tonight has been about how we weighed them, not with a scale, but by noticing that they arrive a few seconds early and a few seconds late because they tug at each other. Tonight has been about how we read their air, not by going, but by catching the sliver of starlight that grazes their edges and looking for the colors that went missing. Tonight has been about the vehicles. 9 billion years on foot, 440 million by car, 49 million in a passenger jet, 1,100,000 at Apollo re-entry speed, 717,000 at Voyager's pace, 63,000 at the speed of the fastest object we have ever built. Tonight has been about the vehicles we have only drawn. 2 centuries on a sail pushed by lasers, 3.5 on fusion designed by volunteers meeting above a pub, 10,000 on a ship of detonations, 1,000 years and 40 generations on a vessel that is not a vehicle at all, but a place, where nobody who boards arrives and nobody who arrives has boarded. Tonight has been about time bending. 43 years for those watching from here, 7 years and 4 months for those aboard a ship holding 1G the whole way. About atomic clocks flown around the world and coming home behind their twins. About the fact that the question how long has no single answer, only a family of answers, each one correct for whoever is doing the traveling. Tonight has been about light, which crosses the whole distance and experiences no duration at all. Photons that left in the 1980s, ending tonight in the back of somebody's eye. A conversation that would take 81 years for one exchange, and would have to be worth saying the first time. Tonight has been about the coast. The long middle. The part where the engine is cold and the fuel is gone, and the crew is asleep, and nothing changes and nothing is required, and the ship holds its speed exactly, because there is nothing out there to take it away. Tonight has been about being carried. Carried by a turning planet at several hundred meters a second, carried around a star at 30 kilometers a second, carried around a galaxy at 230, carried at 600 kilometers a second with respect to the oldest light there is, without ever once feeling it, through every night you have ever slept. Tonight has been about a distance so large it stops being a problem and becomes a permission. Nobody can be late. Nothing can be missed. That star will outlast every deadline you have ever been given, and none of it needs anything from you tonight. The 7 worlds do not need you to remember their order. The resonance does not need you to hold the ratios. The star does not need your attention to keep burning, and it will keep burning whether or not any eye ever turns toward it again. The light that left in 1985 arrived tonight regardless of whether anyone was looking. Voyager will keep coasting after the last instrument goes dark. Without maintenance, without instruction, without us. You do not have to do anything with any of this. Not tomorrow, not ever. You were not given these facts as a task. They were laid beside you the way a blanket is laid beside a sleeping person, in case it is wanted, and if it is not wanted, no harm has been done. If this hour has helped, there will be another one waiting when this ends. You do not have to choose it, or reach for it, or open your eyes to find it. Let it begin on its own if it wants to, and let it carry on into the room, whether you are awake for it or not. Voices are good at coasting too. And if some part of you is awake tomorrow and feels like leaving a word behind, here is the question I have been holding all evening, and I would like to know your answer. If you could send one message toward those 7 worlds tonight, knowing it would take 40 years to arrive and 81 for any reply, and knowing you would almost certainly never hear one, what would you say? Not what would you ask, what would you say? Leave it in the comments if you want to. I read them, slowly, usually at hours like this. Now let it all go. Let the numbers go first. You do not need a single one of them. Let the trillions go, and the ratios, and the names of the telescopes, and the letters B through H. Let them drift out of the room the way steam leaves a cup. Let the day go. Whatever it was, whatever it asked, whatever it left undone, it has finished with you, and it is not coming back, and the parts of it that matter will be there in the morning to be picked up by a rested version of you who will handle them better than you could tonight. Let the shoulders go, one more time. Down and away from the ears. Let the space between the shoulder blades widen. Let the arms be heavy, upper arm, forearm, wrist, hand. Let the fingers uncurl a little where they lie. Let the thumbs rest. Let the face go loose. The forehead smooth. The space between the brows unfurrowed. The eyelids heavy, resting closed without pressing. The jaw unhinged a little so the teeth are apart. The tongue low and wide. Let the breathing get smaller, not deeper. Smaller and lower and further apart until it is happening entirely on its own, down in the belly, without any part of you supervising it. Let the legs be heavy, the hips sinking, the thighs giving up their weight, the knees unlocking, the calves letting go, the ankles, the heels, the soles, the toes, and let the whole of you be held. By the bed, by the floor, by the building, by the rock, by the planet, which is turning you eastward through the dark right now at a speed you will never feel, carrying you around a star on a long, easy, engine-less arc that began billions of years before you and will continue billions of years after, and which has never once required you to be awake. You are aboard. The burn is over. There is nothing left to do but the crossing, and the crossing does itself. Far away, in a direction you cannot point to from where you are lying, an old red ember is holding its steady, unhurried light, and 7 small worlds are turning around it in a rhythm they have kept for billions of years, and will keep tonight and tomorrow, and for every night you have left, and for every night after that. Nothing is asked of you. Nothing is waiting. Nothing can be late. Let yourself be carried. Sleep well.